Hello, welcome to our vlog. Today we will...
Pre, lang do. Wapo nang isang bike ta. Do katupo nga.
Ay, uyo, pre, kay balaan mo may mathematicism na dang involved, pre mo.
Ito, paano mo nakabalan?
Natunay ko na, pre mo, bali, amo ni sao.
Based on Evarista Galwa, symmetry combines beauty and science that can merely exist in the world around us. Also, its regularity means that the shape is identical to another form when it moves, rotated, or upside down.
In Ian Stewart's book, Nature's Numbers, symmetry was further discussed in Chapter 6, Broken Symmetry. In the book, it was said that one of the most familiar symmetrical forms is the one inside where you spend your life. Thus, the human body is called bilaterally symmetric. Bilateral symmetry is a form of symmetry where the opposite sides are similar or can be divided into approximate mirror images of each other. Just like in a human body, the left half of the body is almost similar to the right half of the body.
Amo na sa boy, bali may 3 kinds pagid sa symmetry. Tanawa ni Blau.
There are 3 kinds of symmetry: reflection symmetry, rotational symmetry, and translational symmetry. Reflection symmetry, also called line symmetry or mirror symmetry, is symmetry with respect to reflection where one half is the reflection of the other half. One example is a butterfly. Its wings on the left side is identical to the wing on the right side.
Rotational symmetry, also called as radial symmetry, is a shape that maintains the same looks after some rotation by a partial turn, also an object that rotates on its axis. One of the best examples of rotational symmetry, a starfish. It has a similar parts and it was regularly arranged around the central axis. And the pattern looks the same after a certain amount of rotation. Translational symmetry is a specific translation of an object to another location that does not change its pattern. It doesn't change the distance between points, angles, size, and shape. And these are the examples of translational symmetry: the bricks on the wall, repeating tiles, wallpaper pattern, and a honeycomb.
Amo na sa boy, bali ang symmetry naturally occurring ginaya. Tanawa, blabis kandereo.
As mentioned in the book, nature's symmetry can be found in every scale of the universe. A few examples are: when you throw a pebble in a pond, the water creates ripples or circular waves that moves away from where the pebble has landed and gently moves across the pond in a concentric pattern. Sand dunes are created when, as the wind blows, it pushes the sand ahead of it. The direction of the wind affects the patterns formed in sand dunes.
Nature symmetries can be found on every scale, from the structure of subatomic particles to that of the entire universe. Many chemical molecules are symmetric. Based on Robert Mulliken's molecular symmetry, a molecule has a center of symmetry when, for any atom in a molecule, an identical atom exists diametrically opposite this center of equal distance from it. In other words, a molecule has a center of symmetry when the points positive x, y, z and negative x, y, z correspond to identical objects. And these are some of the chemical molecules that are symmetric: carbon dioxide, methane, and boron trifluoride.
Symmetry in nature can also be found in larger scales. A developing frog embryo begins life as a spherical cell, then loses symmetry step by step as it divides, until it has become a blastula, thousands of tiny cells whose overall form is again spherical.
Volcanoes are conical, stars are spherical, galaxies and whirlpools are spiral or elliptical. Raindrops and stars are spheres, honeycombs, and the Devil's Causeway are arrays of hexagons.
Kaya nga man kita mo na biskan din, pre.
Kay bali boy, ang basa mo mathematician.
Sila nang magic-magic.
Hindi ang magician na iya. Ang basa mo mathematician na ang symmetry naturally occurring ginaya. Pati sa living kag non-living things. Kay bali sumatotal amo ni sa boyo.
Spherical symmetry is characterized by the ability to draw an endless, or great but finite, number of symmetry accessed through the body. For an organism to exhibit spherical symmetry, its body must be shaped like a sphere, and all parts must be arranged or radiate equally around a center point. This universality of symmetry breaking explains why living systems and non-living ones have many patterns in common. Life itself is a process of symmetry creation of replication. The universe of biology is just as mass-produced as the universe of physics, and the organic world therefore exhibits many of the patterns found in the inorganic world. In conclusion, symmetry can be found in every aspect of nature, in animals, organisms, plants, land, water, etc. Through mathematics, the process of symmetry breaking is described in order to explain with unified details about broken symmetry. Broken symmetry is fundamental to everything, in relation to understanding mathematics itself, science, and physics. If the law of nature were not symmetrical, the complexities of the universe are not discovered.
Sindihan ko na boy, si sakto man paano maglaga ng bike kung hindi asymmetrical?
Oo boy, muna siya. Daling vlog kay ma-vlog na ko.
Oh, sige sige.
Hello, welcome to our vlog. What's up mga karastaman? Ay, bilat.
Uy, bilang singilongin.
Wala pa ako ka-vlog, lo. Ba't na? Yot, dugag.